not asteroids, but exoplanets. This is our planets, like the one that we have in our solar system, but they exist around other stars. And I will start by modifying my title, because my title was the planet par milliers, but today we think that we have more than thousands, but billions of exoplanets exist. For now, we have confirmed few thousand of exoplanets, but we know that there are billions of exoplanets, at least in our galaxy, Milky Way. So today, we are going to explore a bit this topic, exoplanets, and try if, like doing research, if we can find some sign of life in this exoplanet. I would like to start with this quote from Carl Sagan, who say, "We are not alone in the universe. The universe is a big place, and if it were just us, it would be an incredible waste of space." And I love this quote. So he mentioned that, and you know Carl Sagan, one of the famous astrophysicists, American astrophysics, who really work on these topics, including the looking for life beyond Earth. So my colleagues talked about many questions this morning about the that we're facing in like philosophy and in science and astronomy. So here I want to raise these questions again, that we consider them as fundamental questions in astronomy. So the first one, which I consider it, that we are still, as human, sorry for this word, we are stupid because we don't know where we are. So this is the first question that we raise, is where we are in this universe. If I ask some of you, so you say that we are on a planet, around in a star, the star is in a galaxy, and this galaxy in an arm of galaxy, and if you go beyond at some point, you will not find your limits. That means that you don't know where you are. And there are some people thinking that maybe we have multi-universe, as Bruno mentioned this morning. And we will talk about that. I will not talk about that this morning, since my colleague John spoke about it, which is the cosmology and the origin of the universe, the Big Bang, and so on. So the second question is, how did the universe begin and how did it evolve? We still have a lot of lack of answers for many questions, including this one, like some question related to the cosmology, to the Big Bang, to the evolution and the formation of the stars, our own star, and also the galaxy. And I will finish with the last question, which I'm going to focus on in this presentation. Are we alone in the universe? I know you heard about it this morning from my colleagues, but I will go step by step through what we're doing now as a scientist, as an astronomer, astrophysicist, to look for life beyond Earth. So for that, we are talking about the exoplanet, the exploration of exoplanets in habitable zones. I will explain what habitable zone is. And also there is some effort going on around the world to look for what we call the biosignature, some signature that if we think that there is some aliens, they might send some signature that we can be able to detect. And as we're human, today we are building big telescopes to do so. So we have built-in big telescopes like James Webb. You have heard about it. And this is one of the most powerful telescopes that humans build as now is GWST, which has been launched to space in 2021, and it costing $10 billion. So science answering fundamental questions is not really cheap. It's really expensive. We have been getting many discoveries, like this beautiful image that we have is showing this cloud and gas in the space. We have been able to take a picture of a black hole that it has been predicted for a long time, and humans now building telescopes like the one, the ELT, I will talk about it later, that taking pictures of black holes like this one, M87, one of the black holes in the center of the galaxies. So I will not go more in details to this plot, since my colleagues talked about it this morning. We're showing the whole idea about how the universe began and how it evolves. So this can be explained by the Big Bang theory that we have talked about it at some point, but we don't know. We have a lot of questions, we don't answer them yet, like, for example, what's happened before Big Bang. And this is why I think one of the topics that bring us today together as philosophers and scientists to discuss this topic. And after the Big Bang, we be able to take a picture of the first photons that escaped from the Big Bang, and this is what we call the cosmic microwave background. And this why Professor John Matter, who got the Nobel Prize because he built the first instrument to look at these photons that come in from the Big Bang later. And as you can see in the slide, after this picture, after the color plays, we have a dark age. We don't know what's happened, and we don't know how we get formed the first stars in the first galaxy. And this is why my colleague John this morning said there are a lot of Nobel Prizes waiting for us because we still did not understand many, many things. So from the whole thing that you see here in this plot, it's all what we can see for now, it's only 5%. 95% is made of what we call dark energy and dark matter. الطاقة المظلمة, المادة المظلمة, which we did not understand the meaning or the physics meaning of these two components of the universe. We can all the discoveries that we have done now so far, they are only making only 5%. And imagine with this 5%, we still did not all the 5%. So we still to make a lot of effort to get to know about this universe that we are part of. My colleague John, again, he showed you the first picture that we got from the photons. This is, by the way, this is the universe when it was baby, when it was 380,000 years old. The age of the universe today is almost 14 billions, not millions, but billions. So what we are looking at now is the most sharp image that we get so far from the Planck Observatory, which built by ESA, European Space Agency. What we can look here, it's a map of the universe when it was baby, and the colors that we see here, they are presenting the fluctuation of the temperature when the universe was hot and dense at this age when it was 380 years old. What we are trying to do as a scientist today, to understand many features in these pictures and try to extract as much as information to learn more about this theory of the Big Bang and to look more about the origin of the universe. Let's back to our home, which is Earth, the planet. This is why I'm going to explore more about, this conference not for me is not about more cosmology, so my colleague talked about it. I will back to talk about life and if it exists beyond the Earth. So this is our planet. If you take a picture with your camera from the ground, and this is one of the pictures I took when I was in Chile, in Paraná, of the galaxy, this is what you can see. This is what we call the arm of the galaxy. And by the way, if you have a dark place, you can see it by your naked eye, like in the mountains or some places without light. Or you can take a picture of it with your camera or with your phone. If we zoom in more, so we can see this. Are the stars, or we call them cluster of stars when we have a group of stars. If we keep zooming out, so we can get our neighbor galaxy, Andromeda, which is like the closest galaxy to our galaxy. And all what you see in this picture, all the white dots are stars, if not are galaxies. And if we keep zooming out, this is what you see. Here in this picture, there is no stars, there is only galaxies. And you can see their shape from this picture that you see here. And if you keep zooming out, you find this. And this is what we call the large structure of the universe. It looks like kind of design of our brain, but this is a simulation of how the universe looks like at large picture. As astrophysicists, we still did not understand how we come up with the structure that we have in the universe, and this is why we're making instruments and making simulation and trying to understand how the universe evolved since the Big Bang after 14 billion years ago. But again, this is the big picture of the things, but let's back again to our solar system this time. And you know, in our solar system, we have 8 planets, not 9, after 2006. So we have the 4 terrestrial planets, Mercury, Venus, Earth, and Mars. And we have the gas planet, Jupiter, Saturn, and we have the ice planet, is Uranus and Neptune. So exploring life beyond Earth, we have to look at the planets in our neighbor. And this is what we have been doing for a long time ago, is to look for life on other places in our solar system before going outside to the solar system. So before searching for life beyond Earth, we have to understand first what's the basics of having life here on Earth. And this is one of the principal criteria that we can consider to have life on Earth. The first one is to have the right elements. We're talking about oxygen, carbon, hydrogen. Without this, we cannot have our life as we know. We need a place when we have liquid water. You know, in the North Pole and the South Pole, there is almost no life because it's too much cold, ice, and you cannot form life there. And we need also the right temperature. The temperature should be like in this range. If you are close to the sun, it's too hot, which is the case for Mercury and Venus. If you are too far away from the sun, it's too cold, which is the temperature is very cold and you cannot make life. And also you need an atmosphere, and especially the magnetic field, which plays a very big role in case of our planet to protect us from all the radiation that's coming from the universe. So thanks to the atmosphere that we got around our planet, and also especially the magnetic field, which protecting us from this radiation. And also we need to have a planet, what we call enough gravity. And this is what Bruno talked about. If we have a small object, if you are on the moon, you cannot land or build or grow things up. So everything will be going away because they have less gravity. So you need to have enough gravity in a given planet to make life. And if you sum up all these conditions, so we can consider ourselves we are in habitable zone. In Arabic, al-mantaqa as-saliha lil-aish. We might not find all the conditions, but we have some necessary conditions that we have to look for, like the atmosphere and also the range of the temperature of the planet, which make us make liquid water. So simply describing what is the habitable zone is the green area you see here. It's not far from the star and is not close to the star. Close means too hot, far means too cold. But this habitable zone, it depends on the size of the star. You know, in the galaxy, we have billions of stars. I will not tell you the number later. And in the stars, we have different sizes, big stars, small stars. For example, in our case, our sun, the habitable zone, the green area, when you can see the Earth is the center, which means that we are in habitable zone. And also, if you look at the edges, you find Mars and Venus. But Venus is quite out of the range, but Mars is considered, and this is why we are considering Mars is one of the potential places in our solar system to host life. Imagine if we change the size of the star. If we make it half of our sun, the habitable zone, it will be smaller because it will be emitting less radiation and the habitable zone will be smaller. And if we make the star bigger, twice than the sun, so the habitable zone will be much farther away. Means that this habitable zone is not like a fixed definition, which is depend mainly more about the size of the star. So, as we mentioned, Mars is considered as one of the potential places to host life in our solar system before looking beyond. So Mars, it's a good candidate because first, it's our neighbor. We can just go, like in a couple of months, we can go to Mars. Other planets we cannot, and I will tell you why later. So all the studies that we have done on Mars so far shows that Mars, it has some potential lives in the past. And this is what NASA and ESA and other space agencies trying to do, is try to find the evidence if Mars has life. We believe that Mars, in billions of years ago, it was like the Earth. It was like a planet like the Earth. But something happened to Mars, which make it losing its atmosphere. And when you lose your atmosphere, you are losing or missing one of the conditions that I have mentioned so far, which means that you will have all the radiation coming to you, evaporating all the water that you will have, and making a planet like Mars as a desert like Sahara. And might be the same scenario could happen to our planet if we did not take care about it from the climate change. So this is one of the reasons why we are studying more in Mars, because we want to learn from Mars how to protect our planet, and this is why we're spending such money on Mars. This is one of the videos that has been done on Mars. Mars, it has liquid water, it has methane, it has all the conditions, but we still did not find. It has rivers. This is why we know that Mars, it has water and many other ingredients like we have here on Earth, the organics. And now it has even a smaller atmosphere, which is not be able to protect Mars from all the radiation that's coming from the space and making all this water evaporated, and also like having a dramatic storms happening on Mars, which is make really life hard to have life on Mars so far. This is one of the craters, the famous craters on Mars, when we can see all on the North Pole, when we can see all the ices on the subsurface, on the surface of Mars, as we can see here on the Earth. So let's go to another place. I will talk only about two because there are many, but I'm talking about the potential ones, places that they might have life on our solar system. Is Titan. Titan It's the moon of Saturn. And remember that it's the only moon that it has an atmosphere in our solar system. And you remember that the atmosphere, one of the important criteria to consider for having a life. This is a real picture of Titan. And on Titan, we don't have lake of water, but we have lakes of methane. And many, many other places. We have visited Titan a long time ago, but the mission was not succeed. And now NASA is trying to send a new mission to Titan, which is called Dragonfly, which is a small helicopter. It's going to fly. For the first time, of course, we have flown on Mars, but this time we are flying on many places using helicopter, which is kind of small laboratory, physics laboratory, which is made many instruments to make measurements. First, on the atmosphere, when we're entering the atmosphere of Titan, and second, why helicopter? Because we can take many measurements from different places. And this is why NASA and ESA, they are interested in this kind of concept, sending new robots, because robots or rovers take more time to walk on the surface, and we don't know what the surface looks like, but this is why we're using helicopters, because we can visit many places in a short period of time. And the second place, which is most interesting as well for life in our solar system, is the second moon of Titan, of Saturn, which is Enceladus. But this time, Enceladus does not have an atmosphere, but has a crust of ice. طبقة من الجليد. It goes up to 100 kilometers. And inside this crust, we have ocean, as you can see in the picture. How we know this, how we know about this, because we were looking through the plumes in the south pole of the Enceladus, as you can see them, and these plumes contain many organics and many elements, water vapor as well, that we have talked about. It's one of the conditions to make life. Most importantly, we explain these plumes are small hydrothermal vents, the one that we have here on Earth, on the bottom of our oceans. And if you have seen National Geography at some point, you have seen this scapes like this one, which we can see this hydrothermal vent, and around this extremely difficult environment, we can see some animals that they are living around this hydrothermal vent. This is a video in our planet. The question is, what is gonna prevent not having the same situation happen on Enceladus? If we got some kind of bacteria or kind of animals living on this bottom of the ocean, we are talking about life. Because here, when we talk about life, we are not meaning human as us. Life means many things. Plants, animals, anything can grow up or can do things we can consider is a part of life. So now, it's the problem, this is like still we did not see something like that on Enceladus, but it's very hard to do because we still did not have the technology to drill 100 kilometers in the ice in Enceladus to go to the sub-ocean in Enceladus to look if we have something like that. But we can use some other instrument development techniques to look at this from the plumes as well. So now let's go out of our solar system, and this is the main topic of the presentation. So if our star is considered as only one star among many in our galaxy, Milky Way, the Tabana. So how many stars you think that exist in our Milky Way? I will not wait for response because we have up to 400 billion stars. So the question is, are there planets around the stars as well? The short answer is yes. We have got the first exoplanets, planets surrounding other stars in our galaxy in 1995 when I was 3 years old. I have no idea about astronomy at that time. So these two guys, Michel Mayor and Didier Queloz, by the way, Michel Mayor was here in UP6P like a couple of years ago, and he was visiting and giving a conference to us, and they found the first exoplanet surrounding a star, which is called 51 Pegasi b. And from that time, we're still finding many, many exoplanets. Today, we're talking about more than 6,000 exoplanets confirmed so far. The technique to detect them is very simple. We called it, the most known one, we call it transit. How it works, when I have a planet passing me and light, you see a shadow on my face. That means that there is something passing between us and the star, and this thing could be a planet. Or we can use other methods like radial velocity or microlensing. I will not talk about all of them because we don't have much time to talk about it. But we are sure today, at least if you go at night in the sky, you have to make sure that each points, bright dot in the sky. It's a star, and each star, it has at least one planet, if not many. We are sure about this. And this is why I changed my title, not to thousands, but to billions of exoplanets. Statistically exist billions of planets like other planets in our solar system in the universe. So as I mentioned, this is the technique we do. You told me how we can determine the size of the planet if we look at it. So if the dip that we see of the brightness in the star is small, means that the planet is small. If it's big, means that the planet is big, like the case of the Jupiter, as you can see in this animation here. Or we can have a direct picture of this kind of exoplanet by blocking the light of the star completely, and you will not see the shadow in my face. And to do that, we need really a big telescopes and use one of the most powerful techniques, which is called optic adaptatives, like the ELT that has been built now in Chile to detect the exoplanet and also look at their atmosphere. So we are finding thousands of exoplanets, but we are not interested in all of them. For example, like the one like Jupiter. They are gas planets. Of course, they have no chance to have life, but we are looking for what we call the terrestrial planet like our planet. And here we have a list. It's not an inclusive list because this is just a part of other list when we have many exoplanets that are like terrestrial planet. But I would like you to pay attention to the small title below each planet, which is indicating how far the planet is from us. The closest planet to us is Proxima Centauri b, which is 4.2 light years away from us. That means we need to go with the speed of the light, which is 300,000 kilometers per second, for 4 years to arrive to this planet, which means with the technology that we have today, no way to do this. Even we find life in other planets, we do not have the technology to go there. Means that we have to take care about our planet, and there is no plan B. Even we find life there, and we will see, we have like some evidence about sign of life in many planets, but we will not be able to go there because these planets are far, far away. The second planet closest to us, it's 11 light years, which means that you have to go with the speed of light, which is 300,000 kilometers per second to arrive, take 11 years to arrive to this planet, which is impossible with the technology that we have today as humans. But among this list of planets, you got a repeated name there. It's called TRAPPIST. TRAPPIST-1d, E, and TRAPPIST-1f and G. This is a system of the exoplanets, was discovered in 2017. Not only one planet, but 7 planets. And we found them around a star which is 40 light years away from us. And as Morocco, we have contributed to the discovery by TRAPPIST telescope, which exists in Oakhamden Observatory. For those who have visited Oakhamden for ski, look at your right on the top of the mountains, you will find a couple of telescopes there that we have used, and I have used also for my PhD thesis to look for exoplanets in the sky. And this is how the system looks like. But importantly in the system, 3 of the 7 planets, they exist in this habitable zone that we talked about. It means that they have liquid water. So, and if we compare them, because they are surrounding a small star, if we compare them to the solar system, so they might fit in the orbit of the Mercury because they are orbiting around a young star, which is a small star. So the last question we will ask you more, it's what about life on this exoplanet? We are not seeing the exoplanet when passing, which is just the shadow of this exoplanet. How we can make sure that it might have life? So to answer this question, we have to look for the atmosphere. And to look to the atmosphere, as astronomers, we deal with light. So we look at the light of the star coming, and once it traversing the atmosphere of the exoplanet, it makes some absorptions or emissions of certain molecules, and we can see that in our instrument. And this is what we call the transmission spectroscopy. We're looking at the transit at the same time at different wavelengths, and for that we can discover how many are the layers of atmosphere and also the type of the atmosphere that exoplanet has. So the principle is very simple. So we have a prism, which is our instrument. When the light comes through it, it gives us the spectrum. And when we have a planet with atmosphere, the light comes through the prism and give us some absorption line that we can see in our plot. We do simple mathematics to this plot. So we extract the original spectrum from the second one when we have the planet, and we got the kind of net spectrum of the exoplanets that we are looking for. And this is the technique that we use. for find which molecules exist in this atmosphere with the extraction by modeling if we can find water and also other molecules like organic molecules in this planet. To do that, we need most powerful telescopes like James Webb and ELT. So we have a nice story with the ELT because this telescope, when the Europeans start looking for a place to have this telescope, they think about Morocco. Morocco was one of the candidates. That time was back in 2007, 2008. Unfortunately, at that time, we don't have enough infrastructure to house a telescope, and now they bring it to Chile, and the first flight is going to be in the next year. China is building one of the biggest telescopes in the world, which is like 100 meters in the diameter to look for the signatures coming from this exoplanet. And this is one of the projects that might reveal about some signature coming from other planets. And the result that we have today that we found, this is the spectrum of the atmosphere of exoplanet. We have found many molecules. And the main one that we're looking for because is the water, and we have found it in this exoplanet, like the WASP-39b that we're talking about. But the question is still more complicated, where this water coming from. Even in our planet, we still did not understand. My colleague Abdulrazak maybe talk about it. Even geologists still struggling how we can sustain the water on Earth, because the water is making 70% of the surface of the Earth. But we still did not understand completely how this water can sustain for the Earth for 4.6 billion years. This is why I mean this question applies also to our planet. As astronomers, we have answer to this question. We have not answer, but hypothesis to this question, which is comets. And this is where I spent my PhD life to study this object, which is comets are small objects in our solar system made of ice, water, 99% of them is water. We believe that this comet, they might deliver water and also organic to the Earth at some point in the early stage of our planet. The question is most complicated since 2017, because we find for the first time that we have objects coming from outside of the solar system, not even from the solar system. And we call them interstellar objects. We have found now 3, and maybe this water and organic that we have on Earth, not delivered by comet within our solar system, but it might be coming from outside of the solar system, which making life much complicated for us as a scientist to discover that, and much complicated than we think. Thank you very much for your attention.
Merci Youssef pour cette perspective absolument fascinante sur la découverte des exoplanètes.